Okay, so let's review. If I'm going to evaluate, first of all, logarithms are
Exponents.
log, base, whatever it is, right? Okay, so we don't have the exponent, right? We'll just make it y. Okay, now write exponential form for me. Okay, what? We're concerned with the what? The base, right? So I have base to the exponent equals whatever's in that parentheses. Okay? So, what's my base? 3. What's my exponent? Y equals 81. Okay? So, now from here, I think you guys could all do this, right? This is 3 to the y equals, we'll just say 9 squared, or 3 to the y equals 3 squared squared, or 3 to the y equals 3 to the 4, therefore y equals 4. I have common bases, so I can compare exponents. Yes, ma'am? So you just backwards, you work backwards. That's good. Can't do it all the time, right? But that's good. You're being able to manipulate the exponents, right? Or manipulating the log. Fantastic. Let's do this one. So I'm trying to evaluate, right? We could even just put exponents. Logs equal exponents. Does that work better? I'm trying to think of the best way for this to just get drilled in your head. Logs equal exponents, right? What are we concerned with? Base. What is the base? 8 to the exponent, we'll just call that y equals 16. Okay. Is there an 8 and 16? Or is there... It's 8 times 2, but is that going to help you? No. So, I'm looking for squares, right? So, what's in here? 4 squared. And what's in here? 2 to the 3rd. Do this nice and pretty. Which is 2 to the 3y equals 2 squared 2 times. I'm just going nice and slow. Okay, make the least mistakes. 2 to the 3y equals 2 to the 4. Therefore, 3y equals 4. Therefore, y equals 4/3. Questions? Jacob? We don't make up quizzes, remember? We don't, yeah. You're just never, you've never been asked one on a quiz? I can give you the quiz. It's going to be a 0 until the test, and then it'll be replaced. But we can go over the quiz together tomorrow if you'd like. That way you've got all the answers to it. Sound good? Okay. Any more questions? Okay. Let's cover this up. That's just highlighting it. We don't want to do that, right? Okay. Check this out. let log a to the n equal x. So I know that exponentially, if this is the base and this is the exponent, is an a to the x equals n equivalent expression, right? All right, so if I wanted to be able to solve for x, I have something new that I want to show you. I'm actually just going to write it out. Okay, so the property of logarithms, I would call it the equality property of logarithms. If I have log 5 to the x equals log 5 to the 2, what is x? You guys know you can do that, right? If you've got a common base, then you can compare. All right, I'm going to do that kind of in reverse. I'm going to say I'm going to take the log of both sides. I could do that, right? As long as I do it to one side, I can do it to the other. So I'm going to say log A, and we're going to put a 10 here, because that is the most common log right there. Log 10 a to the x equals log 10 to the n. Everybody okay with that? Okay, what do we know about this exponent? What do we do with exponents when we have logarithms? Move it to the front, right? Make it pretty. Move it over there. All right, so an equivalent expression would be x times log base 10a equals log base 10 to the n. Everybody with me so far? I have log base 10 and log base 10, and I've got an x in front of this. How do I undo multiplication, Colin? X is not going to be a fraction in this case, and you'll see why later. Just go with the flow for a second, and then I'll tell you. You'll see why in a minute. Okay? Okay. What is the inverse of multiplication? So if I wanted to solve for x, couldn't I divide both sides? Do you see that? I just solved for x. All right, now this is pretty nifty, and you're going to love it, because when you're trying to solve for something, you can use a calculator to solve these, because it's got a log with base 10. That log button on your calculator is log base 10. Okay? So this is going to help you a lot. In fact, you're going to say, why didn't you show us this 2 days ago? Seriously. Okay, because it makes your life a lot easier. Okay, so this right here is called, we'll take this little arrow right here and bring it over here. This right here is called change of base. All right, I've got a very important little example to show you. So change of base looks like a fraction, right? Change of, let's see exactly how I wrote it down here. Change of base means the base is on bottom. See what I did with that? Okay, do you guys see the relationship here? Look at this, and then look at this. Just take a look. This here to here. What's the relationship? It's confusing. Okay. I'll take that. Okay. Do you see this? It says log with a base of a to the n equals x. If I want to solve for x, I can take the log of n and compare it to the log of a. Okay, let's do another one. Now, do you see why I put here? Change of base means base by on bottom. See that base right there? Where's the base? On the bottom. Okay, so let me show you. Let's just do one. You ready? Everybody ready? You guys? I don't think you need to write this down, honestly. Okay? I don't think this is deriving it. I'm showing you a tool. This is deriving the tool to show you why it works. Okay? You're not going to need to derive it. And when we get to the later part of our lesson, we're going to be doing things like this, taking the log of both sides anyway. Okay, so I don't think it's necessary to write this down. All right, so I will solve equations and inequalities by applying the change of base formula and applying the strategy of taking the log of both sides. That's what we're going to do today. And then we're going to define a common logarithm. All right, so before we do anything today, let's do some calculator practice. So, like I said, the most common logarithm is log 10. So if you don't see anything there, you should automatically assume that it's base 10. So everybody put log base 10 4 into your calculator, and you should get 0.6021. Do that now, please. Okay, try, which one you want to try next? This one? I would do it in your calculator like this. Parenthesis, log 5 divided by parenthesis, log 7. Try that in your calculator. Okay, now try this one. I would put in 1 divided by parenthesis 3 parenthesis log 4 end parenthesis, because you're going to have to, there's a parenthesis right here for most of those calculators, right? So you would put parenthesis 3 parenthesis log 4 close parenthesis for this, close parenthesis for the 3. Make sense? If you can't do that, start with log 4, write that number down, then multiply it by 3, then write that number down, then take 1 and divide by that number. That's what you're going to need to do. So you should be practicing this stuff, right? So here's the answer you should get. It's kind of one of those things, it's kind of weird, but even though you're using a calculator, you like put it all in, you hit enter, and if you see the right answer, you're like, oh my goodness, right? It's that thankful, thank goodness, I got it. So if you're not getting that thank goodness, then come by and we'll help you try and get it. Log. Yeah, just as long as your parentheses are all correct. Yes, same thing. You're absolutely right. Ready? Okay, try this one. Let's talk about parentheses for this one. So there's already going to be a parentheses right there. You're going to have to close the parentheses. Then you're going to have, I guess you could put negative. You could put parentheses here, -2, then hit the log, then hit 3, then end parentheses, then end parentheses, then divide, right? Then parentheses. There's already going to be a parenthesis here for you. End parenthesis, -3 log. There's going to be a parenthesis, end parenthesis, end parenthesis. If you don't have parentheses, you're screwed. No, I'm just joking. You're just going to have to take a different type of approach, right? If you don't have parentheses, then it's going to be a little bit more difficult for you. That's why those calculators that we have out here are really nice. How we doing? You ready? Let's see it.
No, 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 no.
No, no, no.
Oh, yeah.
Oh, yeah, huh? No. This is part of your homework. Ready? Embedded. This is embedded in your homework. How's that? You excited?
Well, I was going to be excited.
No, it's embedded in your homework. That's why we're practicing it. Okay? So I would become proficient with this before you begin your homework, because you're going to do your homework and then you're going to try to put these calculations in a calculator, and if you can't put them in a calculator correctly, you're going to be wrong. Right? All right, are you ready to go?
Yes.
Ooh, I wanted to change something on here. Give me a one quick, moving on. All right, so yesterday we did this. Not exactly yesterday. It was on your quiz yesterday, right? So log 2, 64 equals y. We switched it to exponential form, which is 64 equals 2 to the y, right? Where this is your exponent. Then 2 to the 6 equals 2 to the y, 6 equals y. So log 2, 64 equals 6. Okay, you want to see how it changes? Okay, I'm going to make the change right in front of you. Let's change this to $64. How's that sound? I want to show you how much easier this is. Okay. So, using change of base, how could I change this? Remember, change of base means you're comparing, right, where the base is on the bottom. Base on bottom. Okay, so I would say y equals what? Log 64 over log 2. Put that in a calculator. Tell me what you get. I heard it. You should get 6. Is that easier than this? Okay, so that's part of your homework. Okay, did everybody see it? I changed the base. What did I change the base to? Base of what? What is really here when I don't write it? 10. I changed it to a base of 10. Because when we have common bases, we can compare, right? Compare components of it. So I changed the base. You see why I was showing you where that's derived from on that first slide? See how you really don't need to know that part of it to be able to do these? You just have to remember that the base goes on the bottom. Change of base means that the base is on the bottom. Yes, sir. No. You've got to learn how to use change of base. And I will come up with a much better reason for you after my meeting today. I have an Algebra 2 meeting. So I'm going to be talking to the Algebra 2 teachers about math analysis and exactly how much of the manipulating of logs that you have to do. Because I want you to be prepared, right? But I don't want to overkill it. All right, are we ready? Okay, pencils down. Okay, so my first step in this is I can say, let's change it. What did we do in the previous problems on the quiz? How did you handle this? First I'm going to write exponent. Logarithms are exponents. So exponent equals log base parenthesis, right? Okay, so exponent, what's my exponent? X equals log My base is 6 to the 42. Right? Okay. So I'm going to use change of base. X equals log what? 42 over log 6. If you put that in a calculator, you're going to get approximately 2.086. It says 0, but you don't need the 0 because it's not going to round up. Okay, go ahead and write that down. Write that down and then try this one. So, this is what you should have got on the second one. How you guys doing? Got that? 1.9534? You need 4 decimal places. Okay? Continue. Questions? Okay. Let's look at this one. There are 2 ways to do this. Okay? I think I'm going to stick with what I've been doing so far. And if it goes awry, then 6th period will get taught a lot better than you. But I think that we should just continue with what we've been doing, okay? All right, so I'm going to put it over here again. So ignore these steps right here. Just pay attention. Don't write. Jared. Exponent equals what? Log base parentheses. Okay. So what's my exponent? Okay, these are really important because first of all we've got an inequality sign here. So where things go is important. So when you're doing this, you need to remember exponent equals log. Exponent equals log. Exponent equals log. Okay? Because I'm not going to have an equal sign here. All right, so what would I put on this side of the inequality sign? X minus, let me change my color. X minus 5 is greater than or equal to log, what's my base? 12, 9.32. Fair enough? Okay, now I'm going to use change of base. All right, so that I can put this in a calculator. So I still have x minus 5 is greater than or equal to log what? 9.32 compared to log 12. I still need to solve for x. What could I do now? Put it in a calculator, right? All this could go in a calculator, but then what? I still have x minus 5. Add 5 to both sides. So if I were to add 5 to both sides, I would get x by itself. So put that in a calculator, add 5 to it, tell me what you get. Yeah, go. Some of you sound like you're going to pray. Right? You're praying and then you're like, yes, got it. Okay, what do you think I'm going to do with this? If we have an inequality, what do we always do when we have, okay, check it. All right, let's check this. What could I check to make sure this inequality is satisfied? I would try 6. Why? Tamia, why 6? Exactly. It says x needs to be greater than or equal to 5.8983. Well, I don't want to check 5.8983, so I'm going to check a number greater than 5.8983. I'm going to check 6. So if I check 6, I get 12 to the 6 minus 5. Carla? Yep, thank you. Is greater than or equal to 9.32, which is 12 to the 1, which is 12 larger than or equal to 9.32? Yes, it checks. That check's not that bad, right? What, you don't want the remote? Okay, write that down and do this one on your own. Okay, check your answer. Did you get the right answer? Okay, let's check it. Check 5 would be appropriate. If we check 5, you get 4 to the 25th is greater than 30. I'm pretty sure that 4 to the 25th is larger than 30, right? Without even putting in a calculator. So it checks.
Or 0.5.
I don't know. Oh, it should be 1. Did I do the same thing on my check? Oh, I see why. 4 to the 1 would be 4 to the 5th. It doesn't matter. I don't know. Who said it? I thought it was Jacob. Did Jacob say it? I probably just automatically assumed that was perfect. Who said it? Sam?
What?
No. To use 5.
Oh, no, I mean, that was Jacob.
It was Jacob. Yeah. And Jacob said it, so I just assumed it was correct, which it was, right? Yeah. I'm like, yeah, we use 5. That's what Jacob said. See how much confidence I have in you, Jacob? Okay. He's right, but we didn't have to make it that complicated. We could have used just 1. All right. Ready? Okay, pencils down for sure. Okay? No, so we've been using this strategy, right, of change of base, where our exponent is equal to what? Keep going. Log base parentheses. So look what happens. All right, so what's my exponent? We have 2 different exponents. So we can't use this change of base. But we can use the same process of how we derived change of base. Do you guys remember how I derived change of base? I took the log of both sides and then divided. Remember that? Sure. Let's go back and look at it really, really quick. Remember, we took the log of both sides, then we divided, and that's what gave us the change of base. So that's what we need to do with this. If I can't use change of base, then take the log of both sides. So I'm going to go through this quickly, and then you guys are going to write it down, and then the bell is going to ring at 44 minutes, so I'm going to go back. All right, so I'm going to take the log of both sides. Take it all in, guys. Log 4y is less than log 5 to the 2y plus 1. What do I do with exponents when you have logs? Put them in front. So this becomes y times log 4 is less than, put your pencil down, 2y plus 1. I'm going to put it in parentheses so I know exactly that it's the whole exponent times log 5. I need y by itself, guys, so I'm going to distribute. Y times log 4 is less than 2y log 5 plus log 5. Are you still with me? At least you're honest. Okay. All right, you see it? I'm distributing. You guys see it? Distributing. Okay, now I want to get my y's by themselves, so I've got a y on this side and a y on that side, so how could I move this y over here? I'm adding this. I would subtract 2y log 5 from both sides. Okay, are you still with me? Now I have, okay, so which one's bigger? The negative 2y log 5 or the y log 4? Which one's bigger, log 4 or log 5? Log 5. It is confusing. I'm going to leave it. I do not have enough time for this lesson. Okay, y log 4 minus 2y log 5 is less than log 5. Are you with me so far? Nope, not yet. They both have y in common, so what do? No. Take out a y. So what would be left over if I took out a y? Log 4 minus 2 log 5 is less than log 5. You guys see it? Just kidding. You don't even see that, right? Okay, so now what do? I want to solve for y. Divide all of this by log 4 minus 2 log 5. Divide this by log 4 minus 2 log 5. This is all calculator work right here. Y is less than that. Hold on. I just need to say right now exactly what Jacob was talking about. When you solve this, because this log is bigger than this log, I need to be pointing because I'm recording. This log is bigger than this log. What happens when you're dividing by negative? The sign switch. So I never switch the sign, but when you check it, it's not going to be correct, and you're going to know that that sign needed to switch. Try these. Try them. You're going to need to go in your book and look at the examples in your book as well. But it's done just like I did it. Okay? You need to attempt every single homework problem to get credit. It's not going to be fun. Right? I see lips poking out, sad faces. Come on, I count that back, guys. You'll be fine. Have a great day.